So let's start by walking through the demo. What are we looking at?
What we're looking at is a demonstration system that we put together. It's a robot we call Igor. He looks kind of impish. The idea of this guy is to basically demonstrate kind of how versatile the products we make are. So we make these kind of modular robotic actuators. What we're trying to do is really accelerate the speed at which people can build robots, build custom kind of robot-like systems. And so what this is just kind of a fun demonstration of putting it together in something really unique. So it's a mobile manipulator, so you can pick up things like you can with an arm that's bolted to a table. But in this case, we're also on wheels, and just to make things more fun, we're balancing at the same time like a Segway. And so the idea is you can build crazy systems like this really quick. So we put this robot together kind of as a fun demonstration, and it took us about a week to do it.
So the company was founded in 2014?
That's correct.
Can you give me a little bit of the history behind it?
The co-founders of the company, we were all members of the biorobotics lab at Carnegie Mellon. And our claim to fame and our focus was really snake robots. And so we'd been looking for kind of a commercial application for the technology of snake robots. Yeah. And what we wound up doing was basically commercializing the modules.
So tell me a little bit about the actuator.
So the actuator is basically everything rolled up to control the joint of a robot. And a lot of people might think that it's just just motors and gears, but there's a lot more to it to do that. So there's a lot of sensing, there's a lot of kind of embedded control to make the joint go to where you want it to. And kind of the key thing that we build into all of our parts here is the ability to control force. So when you talk about an industrial robot, these things are very strong, very rigid, but they're also very stiff because they're just basically meant to go through space very precisely, and they do that kind of darn the consequences, so you have to put them in a cage because they're dangerous. But with the idea with these is we can control kind of how hard we push. So if we bump into a table, we can just kind of not try to smash it, but just kind of lean into it. And if we build it into a robot like this, the arms are nice and compliant, and the body can kind of push around. So the idea is we want something that can interact a lot more gracefully with the real world.
Is this something that you will potentially be able to scale up to an industrial-sized robot?
People may wind up building end products around this stuff. Lots of times I think what will happen is this is just a fantastic tool for prototyping, right? So if somebody is trying to make a robot to walk old people through a nursing home or something, they may build prototype systems out of this stuff, get up and running real quickly. At the end of the day, they will probably build something special purpose because the system will wind up being cheaper.
Well, thank you so much for joining us.
Absolutely, thanks.